So let's look at this question now. A particle is projected at the velocity of 10 meters per second at 30 degrees above the horizontal, as shown below. So it's projected at the velocity of 10 meters per second at 30 degrees above the horizontal, as shown below. Air resistance is negligible. The particle strikes the top of a wall at the time of 0.25 seconds. Calculate 1, the height of the wall, Ri, the horizontal displacement of the ball at that instant, Ri, the magnitude of the horizontal velocity of the ball at that time, then Iv, the magnitude of the displacement of the ball at that time. So let's take the first question now. Find the vertical height. Vertical height simply means height along the vertical. So using the equation of motion, for the component of the motion along the vertical, we are going to have h is equal to uyt minus half gt squared. Uy represents the vertical component of the velocity of projection, which is basically u sine theta t minus half gt squared. So we substitute. What is u? 10 sine 30. What is t? 0.25 minus half 9.81 is 0.25 squared. 0.25 squared. So what do we do now? We can use our calculator. So if you have a scientific calculator, you can quickly do that. So if you substitute that one there, we are going to have 10 sine 30, you close the bracket, 10 sine 30 times 0.25, you have this, then minus, I have to put everything there in a bracket, half is 0.5 times 9.81 times, you put everything in a bracket, then you press the equal sign, and h becomes what? 0.9434 meters. Okay, so the next one is the horizontal displacement x. Horizontal displacement x will be given as uxt because acceleration along the horizontal is 0. So x becomes, what is ux? U cos theta t. This becomes 10 cos theta is basically cos 30 times 0.25. So if you do that, we are going to have 10 cos 30, you close the bracket, times 0.25. So this is going to give you 2.165 meters. Then the next one says, what is the magnitude of the horizontal velocity at that instance? So the magnitude of the resultant velocity is basically square root of Vy squared plus Vx squared. Vy is what? Uy minus gt. That is the vertical velocity at time t, using the equation that we have shown before. So Vy, what is Uy? 10 sine 30 minus 9.81 times 0.25. This will give you 5 minus, so if I put everything into the calculator, I have 10 sine 30, that's 5 minus 9.81. So you put everything like that in a bracket, times 0.25. You close the bracket, the vertical velocity at that instant will give something like 2.548 meters per second. The horizontal velocity, remember that the velocity along the horizontal is constant. So Vx under Ux, which is basically 10 cos 30, which is U cos theta. So this is U cos theta, which is 10 cos 30. If you do that, that will give you, what is 10 cos 30? 10 cos 30 That's basically 8.66 meters per second. So the value of the resultant velocity becomes what? 2.548 squared plus 8.66 squared. You use your calculator. If you use your calculator there, what will it give you? You have square root of 2.548 squared plus 8.68 squared. So this will give you 9.04 meters per second. Then the last one, find the magnitude of the displacement of the ball at that time. So that is OP. OP becomes square root of what? X squared plus 1x squared. Because if this is point O and this point P, what you are looking for is resultant displacement OP, which has the vertical light. The vertical light there is given to be 0.9943 meters, while the horizontal distance is 2.165 meters. So if you substitute that one there, we are going to have square root of 0.943 squared plus 2.165 squared. So OP equals, you use your calculator again, so that becomes square root of 0.943 squared plus 2.165 squared, and this will give you 2.363 meters. So that is the problem solved. So we have been able to find the vertical height at that time, horizontal displacement at that time, the magnitude of the resultant velocity at that time, then of course the resultant displacement OP at that time. Because this is motion in 2 dimensions, in a particular direction, you have to use the component of the motion in that direction. So because vertical is along the vertical, I have to use the component of motion along the vertical. The vertical component of velocity, the vertical acceleration is minus g. For the horizontal displacement, acceleration along the horizontal is 0. So to find the magnitude of the horizontal velocity at that instant, that becomes square root of vy squared plus vx squared. What is vy? Vertical velocity changing with time. That will give you uy minus gt. You substitute that one there. The velocity along the horizontal is constant. With that, we can also find the resultant velocity. Then after that, you can find, question also says you find the magnitude of the displacement of the ball at that time. What is the displacement of the ball? Is a straight line OP, which comprises of the vertical light as well as the horizontal displacement. Some people can refer to it as the resultant displacement. Okay. All right. So we take one more question from here. I will just extend this question here to determine 2 things. Imagine that this height is not there. It's still the same question. It's still the same question. But I've not decided to reorganize the question in a way that this word is not there. As in the case of a ball is projected at a velocity of 10 meters per second at 30 degrees above the horizontal as shown below, air resistance is negligible. So it was projected at a velocity of 10 meters per second at 30 degrees above the horizontal, and it moved like this. So the question I want to do here is that calculate one, the maximum height reached by the ball. Then 2, time taken to reach the maximum height. I just want to time taken to reach maximum height. So to find the maximum height reached by the ball, I can use the equation in which the velocity along the vertical is changing with time. So I have Vy I have Vy squared is equal to what? Uy squared minus 2gh. When this h is maximum, minus 2gh. So at maximum, vertical velocity is 0. So 0 squared becomes what? Uy squared becomes u sine theta all square minus 2g maximum height. So this is 0. What is u? 10 sine 30 all square 2 times 9.81 maximum height. This 10 sine 30, which is 5 squared, minus 2 times 9.81 h maximum is equal to 0. If you bring this one here, I'm going to say that the maximum height will be equal to 5 squared, which is 25, over 2 times 9.81. You use a calculator to find that, so that you get your maximum height to be approximately 25 over 20. So this will be approximately 1.25 meters. That will be approximately 1.25 meters, approximately. So to get the exact thing, we have 25, then you have 2 times 9.81. So that is exactly 1.274 meters. So if I can round this one up also to 2 significant figures, or 3 significant figures, and just write it as approximately 2 significant figures, 1.3 meters. Then the next one, find the time taken to reach the maximum height. We can also use the equation in which the vertical velocity is changing with time at a constant acceleration. At maximum height, vertical velocity is 0. So you have 0, uy is u sine theta minus gt. 0, this is 10 sine 30 minus 10, you don't know t. 0, 10 sine 30 is 5 minus 10t. So if you bring this one there, 10t is equal to 5. Time taken to reach the maximum becomes 0.5 seconds. But if I'm using the exact value, this will be 9.81. So let's stick with that. G is 9.81t. 9.81t. So I'm going to have what here? 9.81. So that t becomes from 5 over what? 9.81. So the time taken to reach the maximum height becomes 5 over 9.81. Approximately that will be 0.5 meters. But to get the same, to get the exact thing, I can just write it as 9 divided by, that's 5 divided by 9.81, and that will give us 0.5097 seconds, which is basically 0.5 seconds. Okay? So that's that. So we go to the next part of motion in 2 dimensions under a constant force. And what we want to look at in that case is this: what happens if the particle is projected horizontally from the top of an elevation? That's what I want to look at there. What happens if a particle is projected horizontally